Setting up a Siemens S7-1500 PLC is a process of transforming a set of unassembled components into a functional, secure industrial control system. To begin, you need your core hardware, the S7-1500 CPU, a power module, a standard DIN rail, a 24-volt DC power supply, a proprietary memory card, and an engineering laptop running TIA Portal. The challenge lies in aligning your physical electrical assembly with the digital configuration in the software without triggering hardware faults. Following a structured sequence through installation and commissioning prevents common boot failures and ensures the system is ready for the final handover to the maintenance team. Start with the mechanical assembly. Secure the DIN rail, then hook the CPU and I/O modules onto the top lip of the rail and swing them down until they click into their locked positions. This schematic shows the data pathways between the modules. You must plug the U connectors into the back of each module to establish the physical communication bus from the external I/O directly into the main CPU. Next, wire the 24-volt DC power supply to the front connectors of both the CPU and the power module. Here is the SIEMENS memory card, shown correctly slotted in. It is a mandatory component for the S7-1500, yet it is often overlooked during the initial physical assembly. Because the CPU does not have internal load memory, the system cannot boot or execute any code without this card seated in the drive. Deviating from Siemens electrical and thermal assembly standards increases the risk of backplane errors or thermal shutdowns before you even open the software. With the hardware assembled, open TIA Portal to create a digital twin that mirrors your physical rack. This detection window shows TIA Portal pulling the hardware data directly from the rack. Using this Ethernet-based detect feature ensures the software matches the exact part numbers and firmware versions on your rail. After detection, navigate to the CPU properties under Ethernet addresses to assign a unique IP address and a Profinet device name. Now you can define your PLC tags for your inputs and outputs and structure your initial logic inside the main organization block, or OB1. Connect your PC to the CPU with an Ethernet cable, then use the Accessible Devices menu to confirm the PC and PLC are communicating. Right-click the PLC folder in your project tree and select Download to Device, choosing the option for both hardware and software. During this first download, the software requires you to use the Stop All dropdown. This halts the modules to allow the new hardware configuration to load correctly. Completing this download synchronizes the digital twin's logic with the physical processor, establishing the baseline for operation. We now move into cold commissioning. In this phase, we isolate and verify every physical input and output before allowing any automated process to run. First, verify your inputs. Manually trigger your sensors on the floor and ensure the corresponding digital bits flip inside your TIA Portal watch table. Next, verify the outputs. Use the software force tables to manually toggle digital outputs and immediately observe the physical hardware, like a contactor, responding. With the I/O checked, look at the physical CPU hardware to interpret the status LEDs. A steady green light indicates a run state. If you see a flashing red light, the CPU is in an error state. If an error occurs, open the diagnostic buffer in TIA Portal. The highlighted red error log will identify specific issues, such as a mismatch between the configured software and the physical modules. Moving past this phase is only appropriate when the software commands the hardware as expected, confirming the system is operationally safe. If any parameters were tuned during commissioning, upload those actual values back into your project file to create a definitive backup. To prevent unauthorized changes, establish read-write password protection levels in the CPU properties. Finally, generate and print the hardware configurations and tag lists to keep as documentation for the maintenance team. The S7-1500 is now commissioned, synchronized with its physical environment, and secured for long-term operation. With the system online, your next step is to choose a communication protocol for network expansion, such as Profinet or Modbus TCP.